Do you know ancient people looked at the sky and thought Earth was the center of the universe? It sure seemed that way under the vast twinkling night sky. Just imagine, giant spinning spheres carrying the moon, sun, planets, and stars, all choreographed in a cosmic dance around our world. This was the prevailing view for centuries, championed by brilliant minds like Aristotle. But fast forward 1600 years and enter Newton, whose revolutionary law of gravitation shattered the Earth-centric illusion. And the cosmic journey didn't end there. Today, modern physics, shaped by Einstein's mind-bending theories, propels us into the depths of space-time, challenging and expanding our understanding of the universe in ways no ancient astronomer could have dreamed. Welcome to Explore the Curiosity. In this video, we embark on a thrilling voyage through time. From the dawn of human wonder to the cutting edge of modern physics, we'll trace the ever-evolving tapestry of our cosmic comprehension. In the dawn of human history, before the first ink scrawled a story on papyrus, our ancestors gazed at the cosmos with wide-eyed wonder. The tapestry of stars above wasn't just a spectacle, it was their calendar, their clock, their whispered stories of creation. Unlike us, burdened by screens and city lights, their nights were plunged into a celestial symphony. The sun, moon, and planets playing their silent dance across the velvety sky. These early humans, keen observers of the heavens, saw patterns we might miss. The sun's fiery chariot blazed a daily trail, dictating their rhythm of life. The moon, a celestial storyteller, spun tales of light and shadow, influencing tides and weaving dreams. Their curiosity wasn't just whispered in the wind. We find echoes of their wonder in the silent halls of prehistoric caves, where star clusters dance on painted walls and phases of the moon leave their luminous trace. Like ancient storytellers, they etched celestial whispers in stone. Megalithic monuments like Stonehenge aligning with the cosmic ballet above, marking seasons and celestial ceremonies. Animism, the belief that everything held a spirit, infused their world. The sun, moon, and stars weren't just celestial bodies. They were living entities, woven into the fabric of their existence. Rituals and practices intertwined with the heavens, appeasing celestial spirits and seeking answers in the starlit tapestry. Though their understanding of the universe differed from ours, their cosmic curiosity blazed with a primal fire. They were the first astronomers, the first to whisper theories into the darkness. Their knowledge passed down through generations in stories whispered around crackling fires. Their journey laid the foundation for our own, paving the way for telescopes and spaceships, for questions whispered not just under the night sky, but echoing through the universe itself. So remember, the next time you gaze at the stars, you gaze not just at the cosmos, but at a legacy. A legacy born in the wonder of prehistoric nights, etched in stone, painted on cave walls, and passed down through generations. We are the inheritors of their starry-eyed curiosity, forever seeking answers in the cosmic canvas above. Next chapter will take us through the Middle Ages. Imagine a time before telescopes and spaceships, when the night sky was a dazzling mystery. This is the Middle Ages, where towering cathedrals pointed fingers at the heavens, and scholars hunched over ancient scrolls trying to understand the universe. Back then, most folks believed the Earth was the center of everything. Planets and stars danced around it like planets on a merry-go-round. This idea, called the geocentric model, came from ancient thinkers like Aristotle and Ptolemy, and it fit nicely with the religious beliefs of the time. It made humans seem pretty important, right in the middle of God's grand creation. But things weren't quite so simple. Scholars started noticing things that didn't quite add up with the geocentric model. Stars and planets didn't always move in perfect circles, and some observations just didn't fit the puzzle. This wasn't just a scientific curiosity, it challenged the whole understanding of our place in the universe. Thinkers like Thomas Aquinas tried to bridge the gap between faith and reason. They believed that God created a perfect universe, but that we could still learn about it through observation and study. This paved the way for a future where science and religion could coexist, even though they might not always agree on everything. Science, though, wasn't quite the powerhouse it is today. Back then, people relied more on ancient texts and philosophical reasoning than experiments and data. This slowed down the pace of discovery, but it didn't stop it entirely. Astronomers like Regiomontanus built clever instruments and recorded their observations, laying the groundwork for future breakthroughs. Slowly but surely, the cracks in the geocentric model started to widen. New ideas emerged, like the sun being at the center, and the universe being much bigger than anyone ever imagined. It was like a new map of the world was being drawn, with the Earth no longer at the center, but just another planet in a vast and mysterious cosmos. Thinkers like Copernicus, armed with precise calculations and celestial observations, dared to unseat Earth from its cosmic throne. His heliocentric model, placing the sun at the center of the solar system, sent shockwaves through the established order. But without tools to validate his theories, it remained a hushed whisper in the celestial wind. Then came Galileo Galilei, his finger pointed not at scripture, but at the heavens. His telescope, a revolutionary lens crafted with improved glass-making techniques, pierced the veil of obscurity. Mountains on the moon, moons orbiting Jupiter, and phases of Venus all contradicted the perfection and immutability of the celestial spheres. These weren't just celestial curiosities. They were cracks in the geocentric foundation, threatening to unleash a torrent of new understanding. But the Church, a powerful protector of tradition, clung to the old paradigm. Galileo's revelations were met with resistance, forcing him to recant his heresies under threat of persecution. Yet, the seeds of doubt were sown. His observations, meticulously recorded thanks to the advancements in printing press, echoed across Europe, fueling the flames of scientific inquiry. Like and subscribe the channel. In the next chapter, we will see how the scientific revolution changed the way we understand the universe. In the midst of the intellectual upheaval, Johannes Kepler emerged as a cosmic cartographer, charting new territories in the realm of celestial mechanics. Building upon the foundations laid by Copernicus, Kepler's brilliant mind refined the orbits of planets, introducing a mathematical precision that harmonized with the grand celestial ballet. His 3 laws of planetary motion, unveiled in the early 17th century, became the guiding principles that unlocked the secrets of the cosmos. Kepler's contributions transformed the way we perceive the heavens, imprinting his name alongside the giants of the scientific revolution. Meanwhile, as navigators traversed uncharted seas armed with improved tools and guided by advances in mathematics, curiosity about the celestial sphere intensified. Scientific instruments such as the sextant and astrolabe transcended their role in navigation, becoming probes into the intricate clockwork of the cosmos. This era marked a convergence of exploration and understanding, where the cosmic mysteries above were illuminated by both navigational and scientific ingenuity. The seeds of change sown in the Renaissance found fertile ground during the scientific revolution. Telescopes became cosmic windows, unveiling hitherto unseen celestial secrets. Printing presses disseminated knowledge with unprecedented speed. And mathematicians armed with newfound insights deciphered the cosmic code. This revolution rippled not only through the lives of luminaries like Galileo, but also through the very fabric of human understanding, forever altering our perception of the universe. Remember the geocentric model, Earth at the center, a cosmic stage play with flaws in the script? The Middle Ages cherished this script, but whispers of doubt carried by knowledge preserved. And ideas reborn echoed across the Renaissance. Questioning was no longer heresy, it was the engine of progress. One man, Isaac Newton, dared to rewrite the script entirely. He peered into the heavens and saw not celestial clockwork, but the dance of gravity. His laws of motion, precise and universal, dethroned Earth and embraced a universe governed by elegant, predictable forces. Gravity, the invisible hand pulling planets and apples alike, became the star of the show. Newton's revolution wasn't just about celestial bodies, it was about unifying the heavens and earth under one set of laws. The whisperings of the Middle Ages, the breakthroughs of the Renaissance, all culminated in this grand cosmic rewrite. This wasn't just a new script, it was a fresh page in the story of humanity. The day we unraveled the secrets of motion and etched them onto the very fabric of the universe. Before we blast off into the modern cosmos in next chapters of the series, and explore how Newton's gravity, Einstein's space-time, and modern discoveries redefined our understanding of the universe, let's take a detour through time. What did our ancestors think the heavens were made of? What myths and mysteries surrounded the stars in the prehistoric and medieval eras? Share your thoughts in the comments below. Buckle up, because in Chapter 4, things are about to get seriously out of this world. Imagine a universe like a giant clockwork, with planets dancing on intricate gears and the stars twinkling like jewels on a celestial crown. This was the world humans knew for centuries, a world ruled by the Earth-centric model, where our planet sat proudly at the center of it all. But then, in the 17th century, a young man named Isaac Newton came along, armed not with tools and gears, but with the elegant language of mathematics. He didn't just tinker with the clockwork, he shattered it entirely, rewriting the script of the universe with a set of 3 simple yet powerful laws that would change the way we see the cosmos forever. First, Newton declared that objects like to keep doing what they're doing. A rolling ball wants to keep rolling. A still rock wants to stay still. This, he called the law of inertia. But what if something pushes or pulls? Well, that's where the law of acceleration comes in. It says the harder you push or pull, the faster an object will move, but the heavier it is, the less it will budge. Finally, the law of action and reaction reminds us that for every push, there's a shove back. When you jump, you push down on the ground, and the ground pushes back up, launching you into the air. These 3 laws unlocked the secrets of motion. They explained why apples fall, why planets orbit the sun, and why rockets zoom into the sky. Newton didn't stop there, though. He peered deeper into the celestial clockwork and discovered its invisible conductor, gravity. He realized that every single thing in the universe, from the tiniest pebble to the mightiest star, attracts every other thing with an invisible force. This he called the law of universal gravitation. The bigger the object, the stronger its gravitational pull, and the closer things are, the more they tug on each other. Legend has it that a falling apple inspired Newton's greatest revelation. But the truth is more complex. While the apple may have sparked his curiosity, it was his years of mathematical exploration that led him to a breakthrough. He realized that understanding the motion of planets required a new kind of mathematics, calculus. Calculus allowed him to analyze changing rates and infinitesimal quantities, concepts crucial for understanding the gravity. With calculus in hand, Newton unveiled his theory of universal gravitation. This groundbreaking law declared that every object in the universe attracts every other object, with a force proportional to their masses and inversely proportional to the square of the distance between them. He envisioned the cosmos as a vast web of gravitational relationships, with the sun pulling the planets and planets pulling their moons, all choreographed by this invisible force. But gravity wasn't just a simple pull. It became even more complex in situations with 3 or more objects, like moons orbiting planets or planets orbiting stars. This so-called 3-body problem defied easy solutions even with calculus. Despite its challenges, Newton laid the groundwork for future mathematicians and physicists to grapple with this celestial puzzle, paving the way for understanding intricate gravitational interactions throughout the universe. Newton's ideas, like all revolutionary discoveries, didn't meet universal acceptance. The Church, accustomed to the Earth-centric view, initially resisted his heliocentric model. Some scientists questioned the validity of his mathematical proofs, but the evidence spoke for itself. As observations aligned with Newton's predictions and his calculus proved its mettle in solving real-world problems, skepticism gradually gave way to awe. The Newtonian revolution had begun. From the falling apple to the falling stars, Newton's vision of a universe governed by universal laws transformed our understanding of the universe. He showed us that the cosmos, once a playground of gods, was, in essence, a grand symphony, its strings vibrating with gravity's melody. Though centuries have passed, Newton's laws remain the cornerstone of classical mechanics. They continue to guide our understanding of the universe, from the microscopic dance of atoms to the grand sweep of galaxies. Newton's script may have been rewritten by giants like Einstein, but his foundation remains unshakable. His revolutionary ideas sparked a chain reaction of discovery, forever altering the course of science, and reminding us that the universe whispers its secrets to those who dare to listen. Smash that like button and subscribe to unlock the mysteries of the universe, one chapter at a time. Next up, Einstein's mind-bending journey into the heart of gravity. Stay curious. In the early 20th century, a young patent clerk named Albert Einstein shattered the cosmic picture. Not with telescopes, but with thought experiments and scribbled equations. He would rewrite the very fabric of reality, forever altering our understanding of the universe. Einstein's first revolution came in 1905 with the theory of special relativity. He dared to challenge the absolute notions of space and time. Imagine a speeding train. Inside, time seems to slow down and objects appear shorter. To an observer outside, the train itself is squished, warped by its own motion. The key to this cosmic ballet is the speed of light. Einstein declared it a constant, the ultimate cosmic speed limit. No matter how fast you move, light will always zip past you at the same pace. This seemingly simple idea had mind-bending consequences. Time itself becomes relative, stretching and shrinking depending on your motion and gravity. Then came the equation that redefined energy, E=mc². Mass and energy, Einstein revealed, are interchangeable. A tiny bit of mass can release a colossal amount of energy, as seen in the devastating power of nuclear reactions. But Einstein wasn't done yet. In 1915, he unveiled his theory of general relativity, a complete reimagining of gravity. Forget about invisible forces pulling objects. Instead, imagine the universe as a cosmic trampoline. Massive objects like stars and planets bend and warp the very fabric of space and time, creating dips and curves. Objects don't fall because they're pulled. They simply follow the natural slope of this warped space-time. This warping has bizarre consequences. Imagine a space-time dip so deep, not even light can escape. That's a black hole, a region of infinite density where gravity's grip is so strong that time itself seems to stand still. General relativity also revealed a universe in constant motion. Galaxies aren't fixed stars. They're swirling and drifting apart, driven by the expansion of space-time itself. Einstein's universe is dynamic, ever-evolving, a cosmic ballet of gravity, light, and energy. Einstein's theories were revolutionary, facing initial skepticism but eventually confirmed by astronomical observations. His work opened the door to a universe far stranger and more wondrous than anyone could have imagined. We now explore black holes, hunt for gravitational waves, and grapple with the mysteries of dark matter and dark energy. All thanks to the man who dared to question the very fabric of reality. Just a few years after Einstein, Edwin Hubble's observations shattered the static universe model. Galaxies weren't fixed islands. They were hurtling away, fueled by a primordial explosion, the Big Bang. This paradigm shift, confirmed by the cosmic microwave background radiation, revealed a universe with a finite age and a breathtakingly violent origin story. But the universe wasn't done surprising us. Observations revealed that visible matter, the stars and planets we see, only accounts for a paltry 5%. The rest, two mysterious entities, dark matter and dark energy. Dark matter, invisible yet crucial for galaxy formation, remains an enigma. Dark energy, even more bizarre, seems to be accelerating the universe's expansion, driving galaxies further apart. Einstein's dream of unifying gravity with the other fundamental forces remains elusive. String theory, with its vibrating strings of energy, offers a promising framework. But experimental verification remains a hurdle. Meanwhile, the 2015 detection of gravitational waves, ripples in space-time predicted by Einstein a century ago, opened a new window into the universe's violent events. Einstein's universe isn't just vast, it's teeming with potential life. The discovery of thousands of exoplanets, some eerily similar to Earth, has ignited the search for extraterrestrial life. Astrobiology, exploring the potential for life in extreme environments, adds another layer to the cosmic tapestry. The universe continues to unfold its secrets. Next-generation telescopes, like the James Webb Space Telescope, will peer deeper into the cosmos, while advanced gravitational wave detectors will listen for the whispers of black holes and the echoes of the Big Bang. The journey through the universe's understanding is far from over. Each new discovery, each technological leap pushes the boundaries of our knowledge, revealing a cosmos more wondrous, more complex than we could have ever imagined. As we stand on the shoulders of giants like Einstein and Hubble, the future beckons, promising even greater revelations, reminding us that the greatest adventure is the one that never ends. This has been our exploration of mankind's incredible journey towards understanding the universe. We've traveled from ancient whispers to modern theories, and the story is far from over. We've merely dipped our toes into the vast ocean of cosmic knowledge. Will we find life on distant exoplanets? Will we finally crack the code of quantum gravity? The future holds breathtaking possibilities. Put your thoughts in the comment section. If you're hungry for more, join us on this odyssey by hitting that like button and subscribing. Remember, the greatest discoveries are often just beyond the horizon. Until next time, keep exploring the curiosity with us.